Okay, so today we're going to look at FTC Part 1. So Nadine is training for a figure skating competition. So her velocity is given by this function for time that is between 0 and 5. So where velocity is measured in meters per second. And t is measured in seconds. All right, so tell me what this integral means. So what does the integral from 2 to 5 of my velocity function dt in the context of this problem, what does it mean? Perfecto. So the distance she traveled between 2 to 5 seconds. So for time 2 and time 5 seconds. So maybe we need to say that our distance is in what? Distance is in what? Meters. So don't forget we need kind of all of that kind of in there. Okay, so using Math 9, or Mark has some crazy function on his calculator, but I figured it out. Woohoo! But using Math 9 on your calculator, what do you get when you integrate this? Did everybody feel okay about putting this in the calculator? Okay. So you don't put v of t, you actually put the function inside there. So what do you get? Okay, did everybody get that? Okay. Alrighty, so let's do some playing around. So give a general solution for the position function. So that's what I just gave your quizzes back, right? So that's basically telling you to integrate this and find a general solution. So general solution means that I need what? I need the plus c, right? Because it's not a definite integral. Okay, so I want to integrate it. So I'm integrating, this function, negative 2t squared plus a 6t plus 1 dt, yes? All right, so when I find the position function, what is that? So it's going to be a negative, t cubed over 3, right? Plus a 6t squared over 2, so that's actually going to be a what? 3t squared, and then plus a t, and then plus a what? C. So we have to have that constant there. All right, so this is our position function. Yes, so that is our position function. All right, so what about finding the change? So the change in the position between t equals 2 and t equals 5, using that equation in number 2. So what's going to happen when I plug in a 2 inside that position function? What's the, when I plug in a 2, what do I get? So 11.3 repeating, good deal. But I also am going to have a what? Plus a c, good deal. All right, what about the position function at 5? What do I get at 5 if I plug a 5 in there? What'd y'all get? Okay, so 38.3 repeating plus a c. So the change in the position, so what am I going to do? What does that mean? So I'm just going to subtract those, right? So I'm going to do this. Well, what in the world happens? What happens to the c's? They go away, so I don't even need those, right? So I'll have what? 38.3 repeating plus a c minus 11.3 repeating plus a c. So what do I get? Oh my goodness, I get how many meters? 27 meters. What in the world? How are those two things related? From question number 1b part and question number 3. They are identical, right? So they are the same value, same. So what I plugged in my calculator, and just finding the change in the position gave me the identical value. Okay, so let's keep going. So at time equals 2, Nadine is 12 meters from the edge of the rink. So where is she at t equals 5? How many? Perfecto. So how can we do that? Or how did you kind of set that up? What am I looking for here? Could I set it up as a definite integral here? So that's going to be equal to the position at 5 minus the position at 2. So we know that this position here is what, 27 meters? The total position. So at 5 meters here, I can figure out where she is. Okay. So far, so good. So if I wanted to find Nadine's actual position, so her actual position, what could I do? What is that asking me to do? Solve for what? So not the definite, so I'm going to still do an indefinite integral. So I'm still going to have an indefinite integral here, but I need to find, instead of having this special thing back here, remember, instead of having a c, what do I need to have? I need to have a value. I need to have a value. So what could I do to find that? Yes, so I know at time equals 2, then she's how many? She's 12. It's going to be 12 meters, right? So can I set that position, which we already found, so that S of t, if I can remember it, what was it? Negative t cubed over 3 plus a 3t squared plus a t? Or was it a minus a t? Plus a t, yep, plus a t. So that means that if I plug in a 2 inside of there, it's got to be equal to a what? $12? So can I solve for C? What do you got? 2/3, perfect. All right, so the actual position now is going to be negative t cubed over 3 plus a 3t squared plus a t plus a 2/3 is going to be her actual position function. Okay. All right, so this is Fundamental Theorem of Calculus Part 1. So FTC Part 1 for short. So if you have a definite integral, when you are looking at a definite integral, remember when it's set up, the derivative, the derivative is what's inside there, right? Yeah. We'll try again. Hold on. So the derivative is what's inside there. Okay. I don't know why it's not letting me do anything. Trying to record for my missing students and my screen is black. I'm not sure what's happening here. It's going crazy. Okay. Still black. It's always a good sign, right? Okay, so let's try this again. So this is going to be equal to the function. So once you integrate this, so the position, so think about that. So it's the regular function evaluated at B minus the function evaluated at A. So f, little f, is the antiderivative. I give up. I give up. My screen's going black again. I'm giving up.